this video, I'm going to show you how to create a ChatGPT bot that specifically helps you with a research task. And today I'm mostly going to be focused on the research task of giving it a PDF and having it summarize it in a very specific way that is how you want your PDF summarized. To do this, you do have to have ChatGPT Plus. So I just want to kind of let you know that ahead of time. You do have to have that to make your own custom ChatGPT bots. And the other thing I wanted to talk about is I would be wary of trying to make ChatGPT bots that are specifically focused on like asking a broad question, something that you can do in like SciSpace, Elicit, Consensus. In a couple weeks, I'll have another video go out of ChatGPT bots that have already been made to do this. The reason I would be wary of that is to do that effectively, you have to have API access into some form of academic database. And if you don't already work with APIs or know how to, it's probably going to be a better use of your time to use one of the bots that are already created than try to create one yourself. So this is my ChatGPT. To get started, I'm going to come down here and go to my GPTs. You're going to see that I have a few already, and I'm going to go ahead and create a new ChatGPT. So if I click that, it takes me to this screen. And it has configure and it has create. So what I'm going to start with is actually in the create tab, not the configure tab. Because right now you can see in the configure tab, you have name, description, instructions, and the instructions is really blank. What I'm going to do is with create, you create your chatbot using a chatbot. And I do this to start with, and then what I will do is switch over to the configure tab to give more specific instructions once we get the general schematic of the chatbot laid out. So in here, I'm going to say, I want to make a chatbot that takes a PDF of a scientific article and gives a summary of it. So it's going to say here updating GPT, and if we jump over to the configure tab, once this is done, you're going to see the configure tab is going to start getting kind of laid out, and so it's going to start filling in some of that data. So this says, how about we name this GPT Summarize Science, and I'm going to say, let's name it Research Article Summarizer. And so then the next thing it's going to do is generate a profile picture or a picture for this. And it does this using image generation. I generally just kind of let it go with whatever it's going to generate. But if you want a specific image, you can change it later. I think this is actually a pretty cool image. So I'm going to say, I like it. And it went ahead over here. You can see that it added that image in. And now if we go into the configure tab, you see that it's starting to generate this out. So it has the research article summarizer, it has a description here, and it has instructions, and it has the image there. And that's all being filled out by the chatbot. So it's now asking us specifically what types of scientific articles should it focus on? Should it cover a broad range? How detailed do you want the summaries to be? So I said it should work with any research article uploaded by the user. The summary should be separated into the sections of, and I gave it 5 different sections that it should do. So research questions, methods, key findings, limitations, and future work. So now it's saying it's updated, and now it's asking how it would like for me to have it speak. So if I look in here, you can see the instructions in here is your role is to provide summaries of a scientific article. You will focus on extracting and clearly presenting the information under specific sections, research, questions, methods, key findings, limitations, and future work. Ensure accuracy and clarity in the summaries, presenting the facts without personal interpretation or opinions. Cases where article's content is too technical or unclear, ask for clarification or state the limitations in understanding. Avoid overly technical jargon and aim for concise, factually, and easily understandable responses. So that was all generated by the create bot, generated that instructions for it. So now what I'm going to do is test it, and you can test it in the preview section that you see to your right. So I'm going to go grab one of my own articles, and this is just so if it's my article, I know how well the bot is actually performing. So I'm gonna go ahead and download that, and then I'm gonna upload it here. So once it fully uploads, I can send it. So I'm gonna send the message, and I'm gonna see how well is it performing right now. So it's gonna do this thing called searching my knowledge. That just means it's scanning the PDF that I gave it. Okay, so then it gave me this summary out. So it says research questions is, how can IM mobility, IMS, specifically TWIMs, be further developed for the analysis of steroids? Can group 1 metal adducts and their multimers improve the resolution of separation of steroid isomers? And how accurate are the collision cross-section measurements for steroids using the TWIMs compared to previously reported values? Actually, that's a pretty good evaluation. So you can see here in the results, we have the different steroids we're looking at. Can they separate steroid isomers, especially using that multimer value, which is this like the ones off to the right. So any of the ones that say 2M, that's called a multimer. We look at the specific resolution of that. And then we looked at the accuracy of collision cross-section measurements. So that's essentially what it's covering there. The methods, it says the study applied TWIMs to the analysis of group 1 metal adducts and their corresponding multimers for 5 sets of isomers. They measured the ion-neutral collision cross-section using a polyalanine calibrant. That's actually pretty good. Steroid isomers were studied using the monomeric and dimeric sodiated adducts, and their separations and resolutions were analyzed using various parameters. So I like this. I think one thing that I kind of expected it to do a little bit more is go more in depth into the details, but that's something that we can give it instructions to be able to do. So we'll come back to the method section. Key findings: TWIMs successfully separated steroids as dimeric adducts of group 1 metals, offering an enhanced resolution for certain steroid isomers. Dimeric metal adducts exhibited resolutions greater than 1, approaching baseline resolution for at least one set of isomers. This isn't actually, I mean, yes, for at least one set of isomers, but it's for at least one set of metal adducts. It was able to do that. It was able to do that for all the sets of isomers. The study found that nitrogen CCS values measured for monomeric adducts were at 1% error, indicating high accuracy, but they were slightly higher for dimeric sodiated adducts. That's pretty good for key findings. I don't really have much to add except for the phrasing of this one here. The limitation, it says noted discrepancies for multimer steroids. That's correct. And there were challenges in resolving certain isomer pairs, including a limitation in the method's applicability to all steroid types. Future work suggests separation through dimer adducts as a useful technique. That's not really future work. I guess for future research is needed for that, but future studies could also focus on refining the calibration process for CCS measurement. That is something we did suggest doing. Okay, so overall, this is a really good starting point. I'm gonna now give it specific instructions. So we're gonna start with, for the research questions, include a list of all research questions that were analyzed by the article. This one's really simple. I'm just trying to make it consistent. We're gonna do enter. We're gonna say for methods, provide a list of all the methods that's used with the we're going to say with the independent and dependent variables tested by that method. Then list all the instruments used with their specific parameters. So we're asking it to give it more detail than just the methods. I want to know what were the methods used and then what instruments were used. And we might see that it is going to classify instruments as maybe it's the actual instrument. So like for this, it would be like a Watterson FG2S. For other types of instruments, like potentially a survey or something like that. Again, if you're making your own bot, then you can clarify this a little bit more to your field, but I'm trying to be a little bit more broad here. So then after that, we have the key findings. For the key findings section, list the key findings and include numeric values where available. if there is a useful table for findings, create it. And then for the limitations section, identify any limitation that was identified by the author or limitations you identify with the research. And then finally, for the future work section, we're going to say, quickly list a study design for future work inspired by this article. So what we did here was we basically gave it more specific information for how it should craft each of these sections. So we're gonna go ahead and come out of this. This should have auto updated from doing that. You don't have to like save or anything. So I'm gonna come in here, I'm gonna re-upload my PDF, and I'm gonna go ahead and send it. Okay, so now it's given me this research article summary. So it starts with research questions. The research questions is, how effective is traveling wave eye mobility spectrometry in separating steroid isomers when combined with group 1 metal adduction? That is pretty much what we're doing here. And then, can ion neutral collision cross sections be measured using TWIM and used as an additional metric for analyte identification? Those are just a tad bit broader research questions, but they do, the combination of those two do get out everything that this article is trying to do. I would just have like sub questions underneath it. So the methods used was traveling wave eye mobility. The independent variables was group 1 metal adducted steroids and their corresponding multimers and different sets of steroid isomers. Dependent is the resolution of steroid isomers, which is true, and the measured ion neutral collision cross sections, that's all true. Instrument and parameters. The instrument was a water SYNAP G2S, that is correct. Parameters, the nitrogen gas flow, wave height, and wave velocity. Those are the metrics we actually report when we're working with the ion mobility cell, because those metrics can change the data so much. So that's accurate. And then for calibration, polyalanine ions used for CCS calibration, that's also accurate. So this is all accurate, and I think this gives you a lot more information about what's going on than the original summary we got up here, where it was just saying these things were being done. So then we get into the key findings. So the key findings for the resolution of steroid isomers is at least one dimer species. So there it goes, it showed a resolution greater than 1. So this time it got it correct versus the first time it was saying at least one steroid isomer pair. This is actually the correct way to say that, enabling their quantitation. And then lithium adducted dimers of androsterone isomers exhibited the highest resolution with that resolution value of 3.19. And if we come in here, I already checked, here it is. Lithiated dimers of androsteroid isomers showed the highest resolution at a value of 3.19. So that is actually accurate. And it is pulling in those numbers for us, which is what I wanted it to start doing. CCS for monomers and dimers varied with the metal adduct used. Yes, that is one thing that we talked about. We didn't go into a lot of detail because that's kind of an expected characteristic. For monomers, CCS values generally increased with the ionic radii of the metal, also correct. Dimers showed more variable trends in CCS across metal adducts. And then comparison of DTIM's data showed good agreement for monomers, but higher error rates for dimers. That's actually a pretty good high-level overview of the findings of this article. So then we go into limitations. So CCS calibration errors was observed, particularly for dimer species, indicating that polyalanine may not be an optimal calibration for multimer species. The generalization of findings, these findings are applicable to a broader range of steroids and conditions is uncertain, necessitating further research. So that's written a little interestingly, but I think it's just basically saying that we don't know how well these findings will actually generalize to all the steroids that it could be applied to. And then steroid overlapping. In some cases, steroid form multiple conformers or overlapped, affecting the clarity of separation. That's also accurate. So for future work, we kind of changed this a little bit to ask it to actually give not just, okay, broad statements about future work, but actually what is specific studies that could come out of this. So broader application. We could test the TWIMS technique for a wider range of steroids and conditions to assess its generalizability. That is definitely work that has been done after this paper was published. CCS calibration improvement, develop more accurate calibration methods for TWIMS, especially for multimer species. That was future work that I did during my graduate degree. And then mixed steroid samples, evaluating the effectiveness of the dimer addict technique in the separating isomers in a mixed steroid sample. And I will actually show you, that is the next, if I go to Scholar, just search my name again. So that is this paper right here. This paper is exactly what that did. We took all the exact same steroids, and what we did is we applied them in a single mixture, and then we're able to see how well did the separation occur from there. So that all of these studies have been done to some extent by now, but again, this paper was 2018. It was my first published paper. So overall, this is how you would build out your chatbot. You can add in more and more detail, and so whenever you're adding in that detail like I did here, I would do this under the configure section in the instructions instead of trying to go through the create chatbot. What I've noticed is whenever you give it specific instructions in the create chatbot, it will paraphrase and remove a lot of those specific instructions to put in here. So it's a lot better to give it the specific instructions within the instructions tab, but to allow the create chatbot to set up the general format and general instructions, just because it's more prepared to do that. Now, for all of this, what I did is I just uploaded the PDF and then sent it, and it will automatically create this. But you could change these conversation starters, so you can see they appear here. You can change them, so you could just say like, upload a PDF and get your summary. And you see that's updating right there. So if you wanted to do that, I don't really like using the conversation starters anyway, so I would just upload my PDF and kind of be done with that there. You can see that I do allow web browsing, so if it's going to try and pull information from the internet, it can do that. But I'm turning off code interpreter and DALL-E image generation. There's no reason to be generating images in this case. And then the creation of new actions is like what you would need to do if you wanted to set up APIs or something like that for it to go pull information from other places. I don't want to do any of that today. I'm just going to set this up to have the user give it the knowledge it needs and not go out and try and find different knowledge. So overall, that's how you would do it. Then you just need to save it. So in this case, I'm going to go ahead and save it to anyone with a link. So I'm going to go ahead and save it to everyone. I will go ahead and leave the link to this in the description below. So if you want to use this exact GPT bot, you can. I don't plan on really updating it past this though. So if you want to make your own, that is how you can make your own ChatGPT bot to analyze a research article specific to you. If there's other ChatGPT bots you'd like to see me walk through how to make, go ahead and leave me a comment below letting me know what those are. And if you are working on starting your own research and you're trying to figure out what papers to read and how to come up with your ideas from those papers, check out my 30-day research jumpstart guide. That will be available in the link below. I hope you enjoyed this video, and I look forward to seeing you in the next one.